This video will teach you the fundamentals of work and energy and how it is applied on system of particles. So let us first recall what is work and what is energy and how it is related to each other. So in our earlier education, we define work as the product of force and the distance. Meaning to say, a work is done when a displacement occurs due to force applied, and the displacement is on the same direction as the direction of force. Now, what is energy? Energy refers to the ability to do work. So both are expressed in terms of joules. So this is the unit, joules or Newton meter. So how are these two related in the application of work energy method? So in work energy method, or the principle of work and energy, it states that summation of forces is equal to the change in kinetic energy. Summation of forces is the resultant work, or summation of forces times the displacement. So that is the resultant work, while the change in kinetic energy is 1/2 mass times v2 squared minus 1/2 mv1 squared. Or it can be written as 1/2 m times the quantity of v2 squared minus v1 squared. Again, this is summation of force times the displacement, or the resultant work, equals change in kinetic energy. So therefore, the equation is the resultant work, or the summation of force times the distance or the displacement, equals 1/2 m v2 squared minus v1 squared, or it can be summation of fd equals 1/2 m v2 squared minus v1 squared, or positive work minus negative work equals 1/2 m v2 squared minus v1 squared, where m is the mass, that is equal to weight over gravity. So this is the weight in Newton and gravity in meters per second squared. So to further explore this principle, let's try to solve a sample problem. So here, a constant force P acts on the body shown during only the first 6 meters of its motion starting from rest. If the coefficient of friction mu is equal to 0.20, find the velocity of the body after it has moved a total distance of 9 meters. So we are going to solve the value of the final velocity v2. So we have here a given free body diagram. So the body or the system starts at rest, and then a force of 750 newtons is applied. So a displacement of 6 meters is observed after the applied force. Then after 6 meters the force was removed, so the tendency of the block is to move to a certain distance. And now after 3 meters after the force was removed, what is v2? So in order to solve this, we use the summation of work, or the resultant work equals change in kinetic energy. So your mass here is weight over gravity. Your initial velocity is 0 because it starts from rest. So now let us solve for N1 and 2, F1 and F2. Okay, so for position A, so your N1, so by summation of forces along y equals 0, your N1 is equal to 1,600 minus 750 times the y component of the force, which is 3 over 5. So you have your N1 equal to 1,600 minus 750 times 3 over 5. So we have 1,150 newtons, while your frictional force F1 is equal to the coefficient of friction times the normal force. So we have here 0.2 times 1,150. So your F1 is 230 newtons. Now, let us proceed to position B. So, summation of forces along y direction is equal to 0. So, we have our N2 equals 1,600 Newton, while your frictional force for the second position F2 is equal to 0.2 times 1,600, and that is equal to 320 Newton. So here we can substitute summation of forces times distance, or summation of work, equals 1/2 m times v2 squared minus v1 squared. So let us first identify the positive work. So for the positive work, we have here this one, the x component of the applied force, which is given by 700. We have here 750 multiplied by 4/5 times the distance of 6 meters. Then the negative work, so we have minus, so we have here F1, so 230. So since this is in opposite direction, so we have our F1, so 230 multiplied by the distance 6 minus you have your F2, 320 times the distance 3 equals 1/2. Here m is 1,600 over 9.81 times v2 squared minus 0, since your initial velocity is 0 because the block starts from rest. Now, if we try to simplify it, we have, so this is 1/2 times 1,600 over 9.81. So this is 1/2 times 1,600 times 9.81 v2 squared equals 750 times 4/5 times 6 minus 230 times 6 minus 320 times 3. So that is 1,260. So now divide all of this. by 1260. That will be 1260 times 9.81 times 2 over 1600. So v squared is equal v2 squared equals 15.45. Now your v, so take the square root of both sides. v2 equals square root of answer, we have 3.97 meters per second. And that is the velocity after the block move a total distance of 9 meters. So it's your v2, 3.97 meters per second. So don't forget to subscribe.